First of all, it is exciting to see a full room for an evening called Cosmic Anomalies. I mean, the good news with a topic like this is, if you think you don't know the answers of science, neither does anybody here on the panel. So we're all on a level playing ground here. But we have this is a very fun group for me to be with because they're people who I either talk to or want to talk to, and now I get a chance to spend a whole evening with them, and you get to eavesdrop in on this. Konstantin Kakaes. Did I do it right? Second time?
I think so, yeah.
Yes.
I'm still learning.
We have a good ethnic group of names here on the panel. So Konstantin is Bernard L. Schwartz Fellow at the New America Foundation, and also the genesis of this evening because he has a new book out called The Pioneer Detectives, which is about, actually I think you're the only person on stage who's going to be talking about an anomaly that has been fully solved. So you're the only one here who's actually going to give an answer.
I might.
Possibly.
I might be very coy.
Possibly. But again, the purpose of this evening is really to talk about what are the big questions and how do people go about pursuing them. Next time we have Lucianne Walkowicz. I'm going to do this. I'm going to do each person's name twice until I get it.
Choose your own adventure.
Yeah, and then I'm going to do my own twice until I forget my own. She's a collaborator on NASA's Kepler mission, which is, you may know, has been probably the greatest mission for finding planets around other stars. It's greatly expanded our view of the universe and the possibility of there being other Earth-like planets out there. She's also a Henry Norris Russell Fellow at the Department of Astrophysical Sciences in Princeton. And finally, Neil Weiner, not Neil Wiener, who is professor of physics at NYU and is a theorist who, among other things, thinks about dark matter. And maybe you can, I was trying to do this, trying to remember this number on the way over, that if you just sort of hold up your hand, there's something like 10 billion dark matter particles a second moving through your hand? Or?
Well, I think that you're combining two different things. So you have a number, and the number is accurate. But I think what he's alluding to, and I think it's worth keeping in mind as we start this whole discussion, is that the universe is fantastically interesting, and we're very, very ignorant of it. And one of the ways that we're ignorant of it is that there is this huge dark sector out there, which actually constitutes most of what the universe is made out of. And one of the specific things that we know constitutes the dark sector is the neutrino. Neutrino is a particle which is a partner of the electron, has almost no mass, has no electric charge, and can pass through a light year of lead without bouncing off a single time. Hi.
That's a different kind of anomaly. I don't know what's going on over there.
I'm loud enough without it, but I guess but it's hard to record. So the neutrino is something that is a fascinating particle. But what's very interesting is that the sun is actually the most local copious producer of neutrinos, and the number you're alluding to is that through your pinky fingernail, every single second, there are 100 billion neutrinos passing every second. So right now, through this room, we are currently being bathed in neutrinos constantly, and we're totally ignorant of it. Totally, I mean, it's not anything you would notice on a day-to-day basis. So as we discuss the question of anomalies, it's important to keep in mind that we're actually constantly surrounded and bathed by all sorts of things that we are essentially unaware.
And actually, just picking up on that, so one of the incredible things I think about that idea that we're just bathed in this sea of invisible, imperceptible neutrinos. This is actually the part that we know. This is the part that's actually fairly well validated, that we've figured out how to study. And the neutrino is a particle that we're pretty sure is there. There's a lot of,
extremely sure.
Yeah, you can run experiments. And in fact, a week ago, I was in an abandoned gold mine in South Dakota. That's now called the Sanford Lab. It used to be called the Homestake Gold Mine. It was one of the sites of the secondary gold rush that went into South Dakota. Well, after they scooped out all of the gold and the mine was starting to shut down, there was a researcher named Ray Davis who really wanted to understand all these neutrinos that are coming from the sun. And at the time, when you tell somebody, I want to run an experiment to find a particle that can go through, entire, 10 light years of lead without stopping, but I want to kind of like catch it. People look at you like, you know, that's not the kind of thing that we really particularly want to fund. That doesn't sound like good science. So, you know, on a shoestring budget and largely on his own initiative, and Neil can probably tell more details than I can, he came up with an experiment. It was an insanely simple experiment. He figured out that every once in a very, very long while, a neutrino might smack into a chlorine atom and turn it into an argon atom. Now, it's sort of I mean, you don't need to understand anything about what that means, except that it occurred to him that cleaning fluid has a lot of chlorine in it. So if you just fill a tank with a lot of chlorine, sooner or later, a neutrino is going to hit something. So if these particles, these invisible particles, are zipping all over the place, and you just fill an enormous tank with cleaning fluid underground, and you wait, sooner or later something's going to happen. And he waited probably about 20 years of monitoring this and counting atoms to see what was happening in his little tank. And he not only found evidence that there were, in fact, these things were real, they really were coming from the sun, but in fact the number of them was not what people with the theory expected, and it actually caused kind of an upheaval in physics from this big tank of cleaning fluid, and from a true belief that these anomalies, that these things that the theory says should be out there that we aren't quite sure really are, that it's actually possible to track them down. So I want to throw the story to Konstantin as the guy who's talking about the anomaly that we do know the most about, the pioneer detectives. Maybe you can tell me, what were the pioneer detectives trying to detect? What was the anomaly they were after?
Sure. The book talks about a group of researchers at NASA's Jet Propulsion Laboratory, principally, which is in Pasadena, California, just outside Los Angeles. And what they found was an effect on Pioneer 10 and Pioneer 11, which were two sibling space probes launched in 1972 and 1973 to visit Jupiter and Saturn. They were, at the time, explorers in the true sense of the word. Nothing anyone had ever built had been farther away than Mars from the Earth. So they went through the asteroid belt. There were some worries about whether they would survive that trip, which they did without a problem. They went by Jupiter. From there, Pioneer 11 used the gravity assist of Jupiter to go all the way across the solar system to Saturn. After the planetary encounters for both spacecraft, a man named John Anderson, who's one of the men in the book, realized that there was an acceleration slowing both spacecraft down. And that sentence sort of contains what in the book is a much longer and hopefully still lively sort of passage, because I say that he realized they were traveling too slowly. And what I tried to get at in the book is what it means to realize something like that.
Now, let me just pause you here. So these spacecraft are going something in the order of, like, I don't know, 30?
Tens of thousands.
Yeah,
30, so Pioneer 10 was launched at
32,000
miles an hour.
Yeah.
It was the fastest thing ever made when it launched.
And so you can predict very precisely, you know, this thing's going by the planets. We know how gravity works. We know how a spacecraft should move. You can predict very precisely what it should be doing. And basically, he was saying that it was slowing down a little bit more than anybody could explain. Is that right?
That's right, yes. And the way that, I mean, in fact, going by the planet complicates things slightly because we don't know the mass of Jupiter precisely. So when both of them did go by Jupiter, it gave the most precise measure known. If you wanted to weigh Jupiter, sending something that you understand very well by Jupiter is one way to do that. What they did was look at the radio signal from the spacecraft using something called the Doppler effect, which is a change in the frequency of a wave, a radio wave, a sound wave, because the source is moving. You can hear this when cars whoosh by you and you hear them go zoom. That's the Doppler effect at work. If you know the originating frequency very, very precisely, and then you can measure the incoming frequency very precisely, you can infer the speed of the spacecraft.
Okay, so we got two things. We got a very precise way to measure the speed, and we have a very, very precise theory of what the spacecraft should be doing, and then something's not jibing. So what happened?
Exactly, yes. And that precision in measuring the speed is not just of the spacecraft itself. You have the Earth itself rotating, moving around the sun. So you need, in fact, a sort of very detailed knowledge of the solar system, of how the radio wave acts. When the solar wind, for instance, will affect the radio wave. You need a model for the solar wind. So you need many, many things just to sort of measure this very simple thing.
This is where the detective process comes in. Because you have to weed out a lot of uncertainty to figure out if you're even seeing something real.
Exactly. So the reason that this was sort of at all interesting to anybody is because of what Neil works on, in part, the dark matter and dark